Awesome. So we just got through question 2, part A and part B. We saw how we could use either factor and cancel or multiplying by the conjugate to solve these types of limit problems. Now we start to look at C. And just as we did before, we like to recognize, really before we even start the problem, what technique might prove to be useful. It should be clear here that we're going to want to try and get rid of these denominators, right? So there is a common denominator technique. Ours is a modified version where we cancel those denominators out, right? I don't want to get a common denominator because then I'm going to still have a complex fraction, right? So instead, I'm just going to try and cancel all of the denominators out from these two terms here in the numerator. Okay. Now, as usual, before we do that, let's just plug in -6 and let's verify if I really need to do all this work, right? If I really need to do the algebra, or do I just get a number, right? So I plug in -6. Here it would be 2 times -6, -12, plus 8 would be -4 over 36 minus 12 would be 24. Minus 1 over -6 over -6 plus 6 would be 0. Well, quick simplification, 4 over 24 is a sixth. It is a -1/6. Here, these two negatives are going to turn this to be a +1/6. Therefore, 0 over 0, right? So we are indeterminate. This says, all right, we have extra work to do, right? We need to apply one of our algebra techniques to go ahead and solve this. So, like I said, I want to take this and I want to try and get rid of this denominator deal, right? I don't like this fraction, or multiple fractions inside a bigger fraction. I'm going to try and cancel this out. So what I'm going to do here is I'm going to take my limit towards -6. I'm going to just rewrite our terms right now. So this is what we started with. And what I'm going to do is I'm going to multiply this whole thing. So I'm going to take this. I'm going to multiply this whole thing by x squared minus 12 and x, right? So these are the two values in the denominators here and here. If I multiply everything by these, then I'll be able to cancel out each of those denominators as I distribute, right, the terms out. And by multiplying everything top and bottom by each of these, I'm not actually changing the fundamental answer, right? I'm modifying what it looks like, but this term divided by this term is technically equivalent to 1, right? So this expression here is really just equal to 1. So if you multiply something by 1, it doesn't inherently change its value, right? 5 times 1 is still 5. So this is kind of our technique. And what we notice is, as I go through and distribute, let's see, just as I was talking about how these cancel out. So this expression times this stuff, the x squared minus 12 on the bottom here is going to cancel out with this that's being multiplied, because technically that would be in the numerator, right? If you have a factor in the numerator and denominator that are the same, you can go ahead and cancel those out. So the first expression with that multiplication should come out to be 2x plus 8, and then times this x term that was left over there, right? I repeat the same process with the -x squared times these guys. The x on the bottom and the x on the top will go away, and I'll just be left with minus x squared minus 12. And then on the bottom, we'll keep this whole thing, right? Don't mess around too much with this just yet. We're hoping that, like we've seen in the past, an x plus 6 factor will cancel, right? So we already have an x plus 6 here. Maybe we can get an x plus 6 factor up there to cancel as well, okay? So let's do another simplification with that numerator. What I notice is that this becomes 2x squared, right? We're just going to distribute 2x squared, 8x. This negative needs to distribute to both terms as well, right? So it's very important. We put this parentheses here to denote that this negative will go to both. So we get a minus x squared, and we get a minus minus, which would be a plus 12, all over x plus 6, x squared minus 12, and x. Okay, we're getting there, right? So let's take this, let's keep simplifying. So in the numerator, 2x squared minus x squared is x squared. 8x is just 8x by itself, and 12 is 12. There's no terms that simplify to that. And I get x plus 6 x squared minus 12, and x. Now my goal is to factor the numerator. Maybe we'll touch the denominator as well. We can simplify that a bit. But my goal is hopefully in the numerator to get an x plus 6, right? Because we talked about that is the term that's causing the denominator to be 0. So subsequently, it must be also causing the numerator to be 0 if I'm also getting some 0 over 0 up here. Okay? So how do you factor the numerator? Well, of course, I need two numbers that multiply to 12 and add up to positive 8. Factors of 12, 1 and 12, that wouldn't give me 8. 3 and 4 would not come together to be 8. But 2 and 6 seem to, right? So 2 times 6 would be 12, 2 and 6 would be 8. So here we go, we put a 2, we put a 6. Both would be positive to result in both positive here and positive here. All right, that's not too bad. In the denominator, we get an x plus 6. If you want to, you can go ahead and, well, actually, that won't factor, right? So we'll just leave that as is, x squared minus 12, and we'll get the x. Just as we had hoped, this x plus 6 term cancel, all good. Now we go ahead, take the limit, x goes to negative 6 of x plus 2 over x times x squared minus 12. Remember, this is multiplied, so I can put that in kind of any order I want to there. Now we plug in negative 6. In the numerator, you get negative 6 plus 2, which is negative 4. In the bottom, you get negative 6 times 36 minus 12, which is 24. Two negatives go away. 4 over 24 would be 1 over 6, right? So 4 is a factor of 24. We're left with 6 from there. Therefore, we get a 1 over 6 from that, and then a 6 from here when that simplifies. Final answer, 1 over 36. There we go, right? So this limit with all of these kind of complex fractions, all this mess here, we do all this work and we end up with 1 over 36.